And now we're going to talk about measuring segments.
That's really exciting, Mr. Butterworth.
It is. We're going to take some segments and we're going to measure them.
Ooh, I thought we were going to measure stuff. This doesn't look like measuring.
Well, those vertical bars are absolute value, which is like finding length stuff. So I bet it's related.
Okay. So am I correct in saying that like absolute value is how far from zero something is? I think I remember that from algebra.
Yes.
And the
So
shortcut,
first question says, how far is -5 from 0?
well, if I think about that, it's the same distance on either side of zero for like 5 and -5. So couldn't I just say it's anything on the inside we make positive?
Yes. And
Okay.
then using our order of operations correctly, absolute value are kind of like parentheses. So
In
we need
fact,
to do it.
could we call them a grouping symbol?
They are a grouping symbol, yes.
So I've got to do the inside stuff first. -6 minus -4. Oh man, I'm going to minus a negative. I'm going to change it to plus a positive. I think that's a little bit easier to think about.
I agree.
-6 plus 4 I know is going to be -2. And then absolute value makes that +2.
Beautiful.
All right.
Oh, that next one looks scary, but let's think. The absolute value of 51 would still be 51, right? Because that's how far
Yeah.
it is from 0. And then we take care of that negative because that negative is really a multiplication problem outside.
Oh, so we can just do that as -51 and we're done.
Yes.
Excellent. That's absolutely fantastic. All right. The ruler postulate is just basically saying that we can measure things.
Yes, and it's just saying we can connect things to points on the number line.
I like it.
There's a lot of math beyond that we're not going to talk about right now.
Yep, I'm okay with that. Find the difference between two numbers on a number line. Is there a secret word in there that's a hint?
Yes. No, I'm just kidding. It's difference.
So if I had like 7 and -2, the difference between those, what math operation is the difference?
Subtraction, sir.
Oh, so I could do like 7 minus -2 plus, and that equals 9?
Yes. What if we did -2 minus 7?
Ooh,
Could we do
I like
that?
that. -2 minus 7, that's -9. So
What
could
if
we,
this question, instead of saying difference, said the word distance?
well, we
Would
just
that
talked
change the
about
situation?
the word distance when we dealt with absolute value. So if we labeled these as, I don't know, A and B, that say the distance would be like B minus A or A minus B, because we got the opposite things, that would make that.
Yeah, but I like that you put the absolute values in there because we don't want a distance to be negative. When I go to the doctor, they don't say, Mr. Butterworth, you are -7 feet tall. They just tell me I'm 7 feet tall.
It's true, because you totally are 7 feet tall.
Definitely.
So the absolute value makes sure that we don't have negative distances, which a negative distance is a problem.
Yes.
Okay.
Hey, that's what I just said.
Wow, that's pretty cool. We even use just letters that are similar to what we just had.
We're the best. I think they
And
can read that and they don't need us to do anything with that.
could this also have been B minus A?
Yes.
Okay, just wanted to check. All right, distances on the number line. Do we want to have them pause, try these, and then check the answers?
Most definitely.
All right, so please pause now. All right. I hope so too. Do we want to randomly choose some of these to do like we're doing?
I'm just writing them down.
It's true, and you're working faster than me. Oof, I chose a different one. I win.
Choose two lengths that equal the length of AC. So AC is this whole piece. Oh, Mr. Carlson, I bet I know what's going on here.
Could we say that this is Oh, so this is confusing to me. Is this two segments that together equal the length of AC, or is it two segments that have an equal length to the length of AC?
We could answer that in either way, but I think it would be helpful for us to make AC. So could we think of it as AC could be written as two pieces? Yeah, that one. Whoa, you just like zoomed off to infinity there. So AB and then BC.
So we could say that the length of AB and the length of BC, when you put them together, gives you the length of AC.
Yeah, I think that makes some sense.
Could I also say that segment AB plus segment BC is equal to segment AC?
Mm, not as mathematically kind. We will not appreciate that.
What if I wrote the measure of these things?
Then yes.
Okay. And we
But
can,
that's a little bit of clunkier notation, so it's easier to use that bottom notation that we use.
so at some point we will be using that M thing. I wonder if that's going to happen soon, like maybe later today. Wink, wink.
I see what you're saying there.
Hey, this
Now we've
is
got the
something you
segment
talked about.
addition postulate. We just did this. So again, this word here, collinear, means we're
I
on
was
the
going to circle
same
that
line.
too.
Well, I boxed it. I didn't circle it.
And this only works if we're on the same line, but to be fair, I think we're only going to ask them about things like this that are collinear. We're not going to try to trick them or something.
That is true. Does this mean we're going to get to some algebra? I hope so.
I hope so too. Ooh.
Oh, wait,
All
I
right.
want to write down the segment addition postulate. So that said EF plus FG equals EG.
And then I'm going to write down what we're told those things are. So 8x minus 14. And then 4x plus 1. And that equals 59.
I agree. And 8x and 4x, those look alike. So I bet we can combine those and make 12x. And
I think
then
so too.
negative 14 and 1 look alike. So I bet we can combine those and make negative 13.
And now this looks like the algebra problems we practiced earlier this week or last week. I bet that we can solve this the same way. Could we add 13 to both sides and end up with 12x, so that's 0, and 72. Is that okay? I think
Yes.
so.
And then you divide by 12. Some students have trouble with that. The operation between the 12 and the x is multiplication. So now we divide by 12, which I'm going to guess is 6. But wait, we didn't answer the question. We figured out what x was.
Oh man, so what's the question asking?
It's saying what's EF and FG.
Oh, so once we have this, we then have to use x equals 6 in the expressions that we have. I'll do the one on the right, you do the one on the left.
Okay.
4 times 6.
You said 4, and so I wrote down 4. Oopsies.
25. I don't know why I have an extra.
48 minus 14, so that's 44, 34. And does 34 plus 25 equal 59?
Well, 30 plus 20 is 50, and 4 plus 5 is 9, so yes.
Beautiful.
All right, so we have this idea that we have numerical expressions, so like numbers, and we say that those things are equal. So like 2 and 2 are equal. All right, and segments are the same length, so that's like not numbers. We use a word that's new to us. This is the word congruent.
It is brand new.
So things that are congruent are things, and I really like the way that we can describe that if you took segment AB, and I'm going to see if it, let's see if that'll do it, and you moved it
He's getting there, kiddos. He's getting there. He's
Nope,
seeing what he can do.
not
Not
going
going
to
to
work.
work.
And you
You're
moved it
trying
on
to say
top of
if you
segment
move that,
CD. That those exact, if they're the exact same size when you line them up like that, that's what we call this thing called congruent.
is there a fancy word for that movement thing you're mentioning?
I don't know. My brain is kind of rigid right now. I don't know if it can quite get there.
Someday we'll translate that for you.
Yeah. Cool. So things that you can slide on top and that show that they're the same, those are congruent.
Yes.
Ooh, a midpoint. That's exciting.
I drew a segment to get us started.
I was going to draw a segment too.
In midpoint,
Mine's better.
yeah, it's because you use the fancy tool. Midpoint means like the middle point, right?
Sure. Yeah. So I could
That's
put it
going to
like
be like,
there.
right, Mr. Carlson, you take that back. So where mine is relatively correct. Now you can tell yourself it's a midpoint by using these fancy little marks. If you put a mark there and a mark there, that says that those two pieces are equal or congruent.
So if this was like ABC, we could say that segment AB is congruent to segment BC
You could
because
also
those are
say,
equal pieces.
yep, you could also say AB equals BC if we're talking about
Mm.
equality.
And if it's in the middle, is it like half the length of the whole thing too?
Yes,
So I could say like AB is equal to 1/2 of AC.
that's true.
Cool, I like it. Midpoints are fun.
So now we just have the definition of midpoint, but there's also the word bisector and bisect. So to bisect is when you split it exactly in half. So
Now,
some
is this because of in the Greek, bi means two pieces and sect means to cut?
yes, it definitely means that because I definitely know those word origins.
I know. That's why I figured that we'd talk about that. So we're cutting it into two equal pieces.
We're cutting the segment into two equal pieces. And this is interesting because you can do it with a line, array, or a segment and call that a segment bisector.
Could you also call a point a segment bisector?
No, you just call that the midpoint
Okay.
because that point isn't bisecting anything, it's just on the line.
But anything that passes through that midpoint would be a segment bisector.
Yes, which I guess you could do with a plane also, but that would be kind of wacky.
Yeah, it'd be weird. Or I guess any planar figure in that matter.
Now you're scaring them.
Or even three-dimensional.
Oh goodness, now we got them
Nope,
going.
nope, bad. All right, we got some midpoint stuff. So one of the things that we talked about midpoints is saying that PQ, the measure of, was equal to the measure of QR. So we start with the definition.
Ooh, that means we can say 6x minus 7 is equal to 5x plus 1.
Now this looks weird because I've got an x on both sides, but I remember that I can just use the same rules to move things around. So I could do like minus 5x and minus 5x. I'm lining those up under the x's so that we remember that those are the like terms. We're left with 1x. Ooh. Minus 7 is equal to 1. And then that seems pretty quick to solve. If I add 14 to both sides, I was hoping to catch you off and have you just write down what I said again. Sorry, if we add 7 to both sides, we solve that and get x equals 8.
Trying to trick me. And then they have to answer that question. That's their job, not our job.
Ooh, I like it.
And then this has exit ticket, so that's definitely their job.
Do you think this would be a good thing for them to do on their own and then for us to discuss as part of class?
Yes.
I like it. It won't stop recording because I'm in Chrome for some reason.